Welcome back to this week's Temp Tech Bite. Today we are unpacking a new world-first discovery, the first living robot. What you see on your screen right now is a world's first. This is not a traditional robot, nor a new species of animal. It is in fact a new class artifact, a living, programmable organism called a xenobot. While it does not look like much, it can be programmed to move towards a target, pick up a payload, and it can even heal itself after being cut. But how can you program a living organism? Does it have a computer chip inside? Or maybe it's stimulated with electrodes? Well, no. There's nothing inside or a part of it that could be used to program any instructions for the xenobot to carry out. It is 100% a living organism. The reason it can be programmed is because of a phenomena called emergent effects. This occurs when you take two different cells and combine them together. Naturally, you would expect these two cells to carry out their normal functions, but sometimes they will exhibit a new and unexpected behavior. This is an emergent effect. The human body is a great example of this. On their own, our cells do not think or act like us, but when combined together with trillions of other cells, consciousness emerges. The cells in question for the xenobot are heart and skin cells belonging to frog embryos. These two cells were chosen because heart cells contract naturally, while skin cells do not. The combination of these two cells was programmed by the Deep Green supercomputer to locomotive in a certain direction. To make an organism develop or function like this, they had to take advantage of the organic computation that occurs within cells. Even without neurons delivering instructions, there is still a lot of information sharing and cooperation going on in and between cells at any given time. These types of emergent and geometric properties are shaped by bioelectric, biochemical, and biomechanical processes. But to arrive at the best candidate for a functioning xenobot would take millions of iterations, and combining two cells together in such a specific way is a very complex and resource-exhaustive procedure that can take up to a few weeks. To streamline this process, a supercomputer cluster spent 4 months constantly optimizing an iterative evolutionary algorithm to outline ideal genetic assembled candidates for the task that is set. These evolutionary algorithms work much like natural selection, constantly improving on existing models, eventually ending up at what would be deemed the best candidate. Once modeled by this supercomputer, the xenobot was then put together by the researchers. This is an extremely laborious process which involves stripping apart individual cells and reassembling them back together. The final product for this experiment was a functional organism that could carry out a number of programmed tasks, such as moving in a certain direction or pattern, carrying or moving an object, and it would even heal itself together after being cut in half. Interestingly enough, when the xenobots were observed in the presence of other xenobots, some emergent behaviors would begin to emerge. Specifically, the xenobots would often team up and help each other perform their programmed tasks. So truth be told, these xenobots are not yet 100% predictable, especially in the presence of other xenobots. The current first generation of xenobots have a long way to go before they can change the world. But the more researchers learn about these living robots, the more limitless their potential applications become. Imagine putting together xenobots using your own body's cells, including some photoreceptor cells so that they can recognize and navigate their environment. Now, a xenobot like this could be programmed to travel through your body to the brain and destroy cancerous tissues. This is just one amazing application that these could be used for. Among others, researchers outlined that these could be used to transport medication inside the body, target and consume bacteria and viruses, clean up radioactive waste, and microplastics in the ocean, and it could even travel through our arteries, cleaning out plaque. The creation of an entirely new life form in xenobots is truly a testament to how far computer science and human research has come, and we cannot wait to see how it benefits mankind in the future. And that's it for this week's Temp Tech Bite. Please remember to subscribe to the channel, it makes a big difference, so smash that button. And this weekend we are giving away an action camera valued at over $500 for free. So pop on over to our Facebook to see how you can win it. And as always, we will see you in the next one.